Today's video is going to be a quick video by showing you a graphic organizer called Venn diagram to show you how the real numbers are classified. Alright, real numbers is pretty much any number, okay? Any number you can think of. Rational, irrational, integers, whole numbers, or natural numbers, they all fall under real numbers. And with the Venn diagram, that's what I'm showing you. I'm showing you that anything inside this rectangle is going to fall under real numbers. Now, the next step, as you can see, I separated them into two circles. And notice that these two circles are not crossing over. What that means is that any number that falls under irrational is not going to fall under this category over here. Okay? So we're going to go ahead and get started. We're going to get started with a smaller circle. Alright? So, you have an example right here like natural numbers, right? Natural numbers are going to start all the way from 1. And as you can see right here, pretty simple. It starts from 1 and it goes all the way to positive infinity, okay? The reason why I put positive infinity is because there's no way of writing all the numbers, okay? You're going to have 1, and if you were to write them all the way to a million, it's a lot of numbers. Alright, so what this is telling you is that it starts at 1, but it goes on forever to the positive side. Now, the next category is whole numbers, and that includes the 0. Alright, so it's pretty much all the natural numbers plus the 0. Integers, as you can see, is going to go 0 is going to be like your midway point, and then you're going to go all the way to the positive side, and you're going to go all the way to the negative side. So when you have integers, you're including all negative numbers, all positive numbers, and the neutral number 0. Alright? Next is rational numbers. Rational numbers is any number that can be written as a fraction. Alright, so any number that can be written as a fraction is a rational number. For example, 3/4. 0.75 is technically 3/4. So 0.75 still classifies under a rational number. Alright? So rational numbers are going to include integers. They're going to include whole numbers from 0 to infinity. They're going to include from 1 to positive infinity, which is natural numbers. And they're going to include pretty much this whole category. Okay? And then after that, you're going to have the opposite of rational numbers. And as you can notice, when you add the IR to a word, it usually does that effect. It changes into the opposite. So when you have an irrational number, you got to think about the opposite. Now, I just went over a rational number is a number that can be written as a fraction or as a rate. An irrational number is the opposite. It's a number that can not be written as a fraction. Okay? So, for example, we have the square root of 2. The square root of 2, if you were to divide it out or if you were going to try and solve for it, it's a number that's not going to have a terminating decimal. It's going to look something like this. 1.4, 142, 135, 624, and this technically keeps going on forever. And as you can see, there's not really a pattern there that you can follow, and therefore this right here is an irrational number, okay? Because there's no end to it. You're never gonna know. The best bet with an irrational number is to round it off. All right, there's no end to that number. It's gonna keep going on forever. You're gonna keep dividing, and you're not gonna find a pattern. With a rational number, you might have something like 1/3, okay? For example, let me show you this real quick. 1/3, as we know, it's going to be 0.333, and it's going to keep going on forever. Now, why is this not an irrational number? Because you find a pattern, and then this pattern is that the 3 is going to repeat on forever. Alright, so therefore it's not an irrational number because you find a pattern, or because it has a terminating decimal. That means that you finish dividing it out. Alright, so it's pretty much the difference between all the numbers. Now, let's go over some examples of some problems that you might encounter when you're learning this. And it's going to be problems like true statements, okay? True and false statements. For example, you're going to have a statement that says all natural numbers are whole numbers. Is that a true statement? All natural numbers are whole numbers. The bigger circle is including all natural numbers, right? So therefore the statement will be true. Now if you were to say all natural numbers are integers, that's also true, right? Because you're also including it into that category. You can also say all natural numbers are rational numbers. Now, notice that this is all true because you're going into a smaller category, and you're saying that that smaller category falls into the bigger category that, as we can see, is actually true. Now, if you go backwards and you go from the bigger category, which in this case is rational numbers, and say all rational numbers are integers, well, technically that's not true because not all rational numbers are going to be integers. For example, -3/4 is not classified as an integer, even though it's a negative number. But since it's a fraction, it's not going to fall under integers. If you say all integers are whole numbers, then technically that's not true because you have negative numbers. And if you were to say all whole numbers are natural numbers, that's not true because on whole numbers you have a 0. Alright? And same thing as we go into the bigger bigger category, which if we're to say all rational numbers are real numbers. That's true, right? Because they all fall under real numbers. But if you were to say all real numbers are rational numbers, then that's not true, because you also have to include irrational numbers. All right. So hopefully that makes sense. Let me know any comments of how I can make this video better. It's kind of hard to do this video because it has a lot of numbers and it has a lot of concepts. But what I do plan to do is I plan to go over how to put numbers in order on the next videos. But I hope you like this video, and I hope you can watch it. Once again, if you like the videos, go ahead and subscribe. And thank you for watching it. See you next week.